Hey everyone, Brandon Quinn here. Thanks for joining. In today's video, we're going to take a look at a logic puzzle I created for my book Mental Mosaics called To Coin or Not to Coin. So the problem reads, what are the possible amounts of money you can have if you have 0 to 1 copies of each type of coin? For this problem, you should use pennies, nickels, dimes, and quarters, where a penny is 1 cent, a nickel is 5 cents, a dime is 10 cents, and a quarter is 25 cents. Pause the video now if you want to try this problem for yourself, and when you're ready, come back and we'll review the answer. So we need to find all of the sums of coin values that we can derive from using exactly 0 to 1 copies of each type of coin. So what does 0 to 1 copies mean? It means that, for example, a nickel, when you're making a sum, you can choose to use that nickel as part of the sum, or you can choose not to use it. But what you can't do is use 2 or 3 or more nickels. It has to be 0 or 1. So to find the answer, you just need to consider the different ways of combining these coins, and you have to be careful not to exclude any combinations or consider combinations more than once. So what we're going to do in this video is make a table where the top row has each coin, and then the rightmost column has the sum of values. Then each subsequent row has either a check indicating that we're including the coin in the sum or an X indicating that we're not. And on the bottom we'll keep a running tally of all of the sums that we've found. So first we're going to consider the cases where we include each coin exactly once, as well as including no coins. So the no coin scenario is simple, that's 0 cents. If we include the penny, that's 1 cent, nickel is 5, dime is 10, and quarter is 25 cents. Next, we'll consider all of the combinations of selecting exactly 2 coins. So if we have the penny nickel, that's 6 cents, penny dime, that's 11, penny quarter 26, nickel dime 15, nickel quarter 30, and then dime quarter 35. Notice how we're taking a systematic approach here. We're starting with the lowest value coin and fanning out right. So when we started with the penny, we included then the nickel, then the dime, then the quarter. Then when we moved on to the nickel, we only had to include the dime and the quarter. So this sort of fan out strategy helps us prevent ourselves from counting combinations more than once. Next, we'll consider the combinations of 3 coins. So we have the penny nickel dime, which comes out to 16 cents, the penny nickel quarter, which comes out to 31, the penny dime quarter, which comes out to 36, and the nickel dime quarter, which comes out to 40 cents. And lastly, let's not forget the combination of all 4 coins, which comes out to 41 cents. Let's do a quick sanity check on our results. So we've found 16 sums. Let's check if that's the correct number of sums in this case. The total number of sums we should be able to derive should be equal to the number of ways we can choose 0 coins from 4, plus the number of ways we can choose 1 coin from 4, plus the number of ways we can choose 2, plus the number of ways we can choose 3, plus the number of ways we can choose 4. We can phrase that mathematically as stating that the number of sums is equal to the sum from C equals 0 to 4, 4 choose C. Fortunately, we don't actually have to do all of that calculation ourselves because that reduces quite nicely to 2 to the 4th power, which is equal to 16. So with that, we have all of our sums of combinations of coins with exactly 0 to 1 copies, and our sanity check does tell us that we have the correct number of sums. I hope you've enjoyed this puzzle. If you did, I highly recommend you check out my puzzle books Mental Mosaics and Hexachi, where I have hundreds of puzzles on a wide array of topics and difficulty levels. Links to both books are in the description below. Thanks for watching, I'll see you next time.